In this video, we are going to do integration by parts. Now this is a method that is one of the most important one when we are doing our integration. Now if we have two functions multiplied such that u and v, assuming both are functions of x, then integration of parts says that we'll use this particular formula u integration of v minus integration of differentiation of u integration of v and then integration of this whole term. So in this manner we are going to use our integration by parts. We are going to use this particular formula. Now in this particular formula it's very important to recognize which particular term is going to be our u and which particular term is going to be our v. For that we have a term liate, L-I-A-T-E, in which L is for log, logarithmic, I is for inverse, A is for algebraic, T for trigonometric, and E for exponential. Now in our course we are not going to see any inverse or we are not going to see any trigonometric. So we have only three terms. We have logarithmic, we have algebraic, and we have exponential. And we say that in this particular term, if we go from the left side, the first term that we find is going to be our u, and from the right side, first term is going to be our v. So basically, if we have a term where we have a log value, a function of log, then it will always be u. If we have an exponential, exponential is our e raised to x or a raised to x, both are exponential. So that will be always v. And algebraic, depending on which one we have, log or exponential, can be taken as u or v. Now simple example, we'll take integration of x e raised to x. Now in this case we can see our x is our algebraic term and e raised to x becomes our exponential. Exponential is always v, therefore x becomes our u. So here we'll follow our formula. We'll take u constant, integration of our v minus, we'll say integration differentiation of x with respect to x, and then integration of v, so that is e raised to x dx, and then whole integration. So we know integration of e raised to x is nothing but e raised to x, so we'll get x e raised to x, and then minus, here differentiation becomes 1, so we'll get integration of e raised to x dx. So finally we get x e raised to x minus e raised to x, or you can take e raised to x common and you'll get x minus 1. So this becomes our integration of x e raised to x using integration by parts. Now what if we had integration of x square e raised to x? So if we have x square e raised to x, we'll again use our integration by parts. We'll say u constant, that is our x square, integration of e raised to x minus integration differentiation of our x square, integration of e raised to x the whole dx. So now here we'll get x square e raised to x, and then minus, we'll get differentiation of x square is going to be 2x, so we'll get integration of 2x e raised to x dx. Now if you see, this term has again integration of x e raised to x. If I take 2 outside, I'll get again integration of x dx. Now because I have just solved this, I can directly use this particular answer, and we'll get our x square e raised to x minus 2 times e raised to x into x minus 1, or you can say you can take e raised to x common and we'll get x square minus 2x plus 1 or you can say e raised to x, we'll get x minus 1 whole square. So in this manner we can solve our terms when we have two functions multiplied with each other using integration by parts. Now just by looking at this, if I had integration of x cube e raised to x dx, we will get a term when we use integration by parts, we will get a term of integration of x square e raised to x, and when we solve this we'll get integration of x e raised to x. So the power of this x will determine how many times we might have to do integration by parts. Now we'll take a few more examples. Let's say if I have log of x. Now here you can clearly see we have only one term. We do not have two terms multiplied with each other. We have just log of x. So when we have log of x, what should we do? Now whenever for this particular term we take that we have two terms, that is 1 and into log of x. So this is the only way of finding the integration of log of x. So we'll say our 1 is algebraic and log of x is our log. And according to our formula, that is that LAE, our log will always be u. So if log is u, our algebraic becomes v. So here we will take our log as u, so our formula becomes u as it is, so log x integration of v, so integration dx, then minus integration differentiation of u, that will be log of x with respect to x, integration of v, so that is integration dx, then another dx. So integration of our dx is nothing but 1, so we'll get log of 1 will be our x, so we'll get log of x into x minus differentiation of log of x is going to be 1 by x, so I'll get 1 by x into x dx. So again this becomes 1 by x into x, so we get x times log of x minus integration of 1 will again get x, so this becomes x times log of x minus 1. So this is how we will solve integration of log of x. Now let's take into consideration the second one, that is integration of x log of x. So clearly here we have two different functions, we have x and we have log of x. So here again log should always be u, so we'll say we'll get u constant integration of v minus integration differentiation of x, integration differentiation of u, and then integration of v, another dx. Okay. So we'll get integration of x is x square by 2, so I'll write it as x square by 2 log of x minus differentiation is going to give me 1 by x and integration of x again x square by 2 dx. So clearly here I'll get another x by 2, so integration becomes x square by 4. So I'll get minus x square by 4 dx. So our final answer is going to be x square by 2 common, log of x minus half. So this is how we'll solve any term in which we have log of x multiplied with some function of x. Now let's see the third one. We have integration of x cube e raised to x square dx. Now in this, clearly we have two functions multiplied. We have x cube and we have e raised to something. Now this e raised to x square is not just one function. The single function is our e raised to x, or you can say x square. This e raised to x square is not a single function. This is function inside a function. Whenever we see function inside a function, we should always use our substitution method. So whenever you see e raised to some power of x, you should always substitute it. So in this case, we will substitute our x square as, let's say, t. So when we differentiate, we get 2x dx is equals to dt. Now we will substitute, and clearly to make dt, we will have to substitute one of the x's here, and the other x square becomes our t. So we will get integration t e raised to t dt by 2. Now we can use our integration by parts. So 1 by 2 outside, we will say t is going to be our u. So integration of e raised to t dt minus integration of differentiation of t, integration of e raised to t dt, another dt. So we'll get half t e raised to t minus integration of e raised to t dt. So that is clearly our e raised to t minus 1. Now we'll substitute our t. T is nothing but our x square. So we'll get half of e raised to x square minus 1. So this is how we can solve these terms. Now we will take one more example. Let's say we have integration x e raised to minus 2x, something like this, dx. Now clearly this is also using integration by parts. Now don't take this minus 2x as t, because that is not going to make much of a difference. We know that whenever a constant is multiplied, we can while we were doing our linear equations, we know that we'll just divide by the constant that was multiplied to our variable. So we will say that we have our x as u and e raised to 2x as our v. So we'll get x integration of e raised to minus 2x dx minus integration of dx by dx integration of e raised to minus 2x dx and another dx. So we get x integration of e raised to minus 2x is going to be e raised to minus 2x upon minus 2 minus differentiation became 1. So integration of e raised to minus 2x by minus 2 dx. So minus 2 is constant. Again we will integrate that. So we get x e raised to minus 2x on minus 2 minus of, we will say e raised to minus 2x upon minus 2 square. So you can take whatever common you want. You can solve it however you want. So this is our final answer. This is how we will solve using integration by parts. Up till now, we were doing our indefinite integrals, in which we were just finding our functions that we were getting after integrating our values. We were not putting any single values. As I told you, we find in integration our area under the curve. Now if we do not specify we are finding our integration from what point to what point, that becomes our indefinite integral. Now if I specify, if I say that integration from a to b, let's say f dash x, I am saying it is differentiation of fx, so that we know that we are going to get fx as our integration. So now here I am saying I am integration this particular function of our x. So when we integrate, we will get our f of x. So after that we say that we will put our limits a to b. So these are our limits where a becomes our lower limit and b becomes our upper limit. So we are integrating from a to b. So that gives us this. Now after finding our indefinite integral, we should put our limits like this a to b, and we'll say it is always going to be our function final value we'll put our x as upper value minus we'll put our function lower value. So this is how we will find our definite integral. We should get a constant value without any values of x, because we have substituted all values of x as our upper value minus lower value. So this is called as definite integral. Now we just solved this particular sum where we had x e raised to minus 2x dx. Now let's assume that if we had something like 0 to infinity. So these are the two limits that we have. So what we'll do is we'll solve it like an indefinite integral. After we have finished all our integration, we are going to put our limits 0 to infinity. Now in this term, when we put limits, what you can do is you can put all the values first of all of our upper limit. So we'll get infinite e raised to minus infinite by minus 2 minus e raised to minus infinite by 4. This is our upper limit, minus we'll say our lower limit, that is going to be 0 into e raised to minus 0, or you can just write e raised to 0 upon minus 2 minus e raised to 0 upon 4. So this becomes our upper limit minus lower limit. Now especially when we have infinity, we'll say e raised to infinity will always be an infinite value, or anything raised to infinity. If I say a raised to infinity, that is going to be infinity if our a is greater than 1. If our a is less than 1, then it becomes 0. I'll just give you an example. If my a is half, we'll say half squared is going to be 1 by 4, cube is going to be 1 by 6, raised to 4 is going to not 1 by 6, 1 by 8, raised to 4 is going to be 1 by 16, then 1 by 32, and so on. As we can see, as we increase the power of our increase the value of our power, basically the term is becoming smaller and smaller and smaller. So the highest value that we can reach is going to be our infinity. So if our a term is less than 1, then it becomes smaller and smaller and smaller, and we say that it will become equal to 0 when we reach our power as infinity. So a raised to infinity is equal to 0 if our a is less than 1. Now e is actually more than 1. So e raised to infinity is going to be equal to infinity. But when we say e raised to minus infinity, so e raised to minus infinity, we can say it is 1 by e raised to infinity. That we will say it is 1 by infinity, and 1 by infinity we say is going to be 0. So e raised to minus infinity becomes 0. So this term is 0. So 0 into anything we will take it as 0. This term is also 0. So our upper limit becomes 0. And in this lower limit, 0 into anything should be 0. And here we'll get 1 by 4. And minus 1 minus here, 1 minus here, it will be plus. So we get our final answer as 1 by 4. So this is how we'll put our limits to find our final answer, and you will always find this final answer is going to be a constant value irrespective or constant from x. There will be no x in our final answer. Let's do double integration. Now when we talk about double integration, what we have here is we have a function that is function of two variables, and we are integrating with respect to both. So whenever we have a function with two variables and we have to integrate with respect to both, we have to take care of one thing. We can, first of all, I have written dy dx, you can write it dx dy as well, but it's like I am integrating first this particular term. So when I am integrating this particular term, the limits on this integration sign should have limits of y, and this integration sign should have limits of x because I am going to integrate it later on. Now whenever we have double integration, you can integrate whichever you want first. Now and the other actually stays constant. So if I have integration of, we'll take a simple example, let's say 2u plus v by 3000 dv du. Now in this case I have taken two variables u and v, and we have a function in both u and v. Now here what we can do is, whenever we are integrating with respect to v, we are going to take u constant. Whenever we are integrating with respect to u, we will take v constant. And the thing is, we can integrate whichever value we want first. Now we will take limits, let's say that our u is between 10 and 20 and our v is between -5 and 5. So because we have written dv first, we will take the inner value and we will write the limits of v there, and the outer will have limits of u. So in this case we can easily recognize that v has the limits -5 to 5 and u has the limits 10 to 20. So now when we integrate, first of all 1 by 3000 is just a constant, it will come out, and then we will integrate with v first. We can integrate with u first as well, we'll see that afterwards. Now when we integrate with respect to v, our u is going to stay constant. So this 2u, both the terms are just constant. So we will have 2uv because constant integration of 1 should be equal to v, and then plus integration of v will give us v square by 2. Then we'll put our limits -5 to 5, and then we'll have du. Now when we put our limits, we'll have 1 by 3000 as it is, integration 10 to 20. When we put our limits, we'll say our upper value. So we'll have 2u into 5 plus 25 by 2 minus lower limits, we'll have 2u into -5 plus we'll have -5 square, so it's just 25 by 2. So this becomes our limits, upper limit minus lower limit. Now plus 25 and we'll get -25, they will be cancelled out. Then we have 2u into 5 and minus will get a plus, and therefore we get 2u5 here as well. So finally we get 1 by 3000 integration 10 to 20, and we'll have 20u. So 20u du. Now we'll integrate with respect to u. So we get 1 by 3000 20u square by 2, and we'll put our limits 10 to 20. Again upper minus lower, so we'll have 20 square, that is 400 into 10. So we'll have 4000 minus, we'll have 1000. So 3000, so this should be equal to 1. So our final answer becomes equal to 1. So this is how we will double integrate. Now we'll see the other way around. In this case, what we did was we integrated with v first. Now what if we integrated with u first? We'll see that. So I can write this as integration minus 5 to 5, 10 to 20. We'll have 2u plus v upon 3000. We'll say du dv. Now if you observe, I have changed my integration, but also I have changed my order of our du and dv. It should be in the same order, or you can say the opposite order of our integration of limits. Our inner value should follow this particular rule, that we'll integrate this first and then we'll integrate the outer part. So now we'll integrate with respect to u first. If we are integrating with respect to u, our v stays constant. So 1 by 3000 outside, we'll have minus 5 to 5. And the integration is going to be, the integration of 2u becomes 2u square by 2. And v is constant, so v into u. And our limits 10 to 20 and then dv. So we get 1 by 3000 minus 5 to 5, and we'll put our limits. So we'll get 400 plus 20 minus 100 minus 10. Okay, my mistake. We'll have 20v minus 100 minus 10v dv. So we are getting 1 by 3000, integration minus 5 to 5, and we have 300 plus 10v dv. Now we will integrate with respect to v. So we'll get 1 by 3000. We'll have 300v plus 10 times v square by 2 minus 5 to 5. Now we'll substitute our values. 1 by 3000 as it is. And here we'll get 300 into 5 plus we have 5 into v square is 25 minus we'll have 300 into minus 5 minus we'll have 5 into, now minus 5 square is again 25. So this plus 5 into 25 minus 5 into 25 cancels out, and here minus 5 becomes plus. So we will actually have 300 into 5, 300 into 5, that is 300 into 10, so we will have 3000. So we get again 3000 by 3000, that will be equal to 1. So in the both cases, when we integrated with u first or we integrated with v first, we got the same answer. So similarly, we will get the same answer. Does not matter if we integrate with u first or v first, it is going to give us the same answer.